Good afternoon, everyone. Just confirm, am I audible to you?
Yes, sir.
All right. So in the previous class, we completed argument and properties of argument. Okay. So till now we have completed. We have learned two types of representation of complex number. One is the general form. I will write it again. Okay. General form, standard form of complex number, which is z equals x plus iota y, right? Then you have studied the polar form of complex number. What are x and y? X are real and imaginary parts. Then in polar form of complex number, it is r into cos theta plus iota sin theta. What is r? R is the modulus of complex number and theta is the argument, right? The principal argument. Now we are going to learn the third form of complex number, but because before that you need to learn a new formula which is called Euler's formula. Okay, and the formula is e to the power iota theta equals cos theta plus iota sin theta. What is this e? This is same that used to appear in logarithm. Okay, e is Napier's constant. It is not a simple alphabet like a b c d. It is a constant. Napier's constant. Its value is roughly 2.713. Okay, but we do not write 2.713. We use e only, right? So there is this formula that e to the power iota theta is cos theta plus iota sin theta. And similarly, there is another formula of Euler's. Okay, here theta is replaced by minus theta and it comes out to be cos theta minus iota sin theta. You need to remember these two results. Okay. Now what we are going to do with this Euler's formula and with the help of polar form. Okay, because see this particular term is appearing here. I am going to introduce a new form of complex number which is Euler's form of complex number. Okay, so you should be comfortable with all the three forms. Okay, you can be given complex number in the general form or in the polar form or in the Euler's form. So now see this is your polar form and now you have some formula for cos theta plus iota sin theta. Okay, so what will be the changes now? In place of cos plus iota sin theta I'll be writing r into e to the power. This voice is getting repeated. What is it? Eagle, it is from your side, I think. Okay, so got it. This part cos theta plus iota sin theta. Okay, cos theta plus iota sin theta. This can be written as e to the power iota theta, where e stands for Napier constant. Okay, theta is same. Theta is your principal argument. Okay, and what is r? R is modulus of complex number. Actually, it is another way to write polar form only. Just this formula, modulus of z. So like if the question is if z equals to cos, sorry, 2 e to the power iota pi by 3. Suppose it is written in this form. Then express z in standard form. Suppose this is the question. So the complex number is expressed in ILS form, okay, and you have to write it in standard formula. So what you will do?
Sir,
Yes.
sir, can you please zoom out? Thank you, sir.
All right. So the question is if z equals to e to the power iota pi by 3, then express z in the standard form. Okay. So what I will do? I will use the formula for this thing, e to the power iota theta. What is the formula? Just now we discussed, it is cos theta plus iota sin theta. Okay. This thing, this pi by 3 will be written in place of theta. So this is actually the polar form now, but you want to write it in the standard form. So you will write the values of cos and sin. Cos pi by 3, cos 60 degree. Sin pi by 3 means sin 60 degree. Okay. Now you multiply 2. So the value will be 1 plus iota root 3. Okay. So this is your complex number in the general form, written in the form of x plus iota y. Okay. So this is ILS form. So it can be used anywhere. In any question, they can express complex number in ILS form. So by these steps, you can change it in the standard form. Okay. Now the next result which is related to the chapter is de Moivre's theorem. Okay, de Moivre's theorem. So what is the result? If n is any integer, then cos theta plus iota sin theta whole power n. This is very important theorem. Okay. N is any integer, then cos theta plus iota sin theta whole power n can be written as, see the changes from left to right side. What happens? What is the form of the expression on the LHS? It is cos plus iota sin. Always remember this. You can use only when the same expression is present. Cos of some angle plus iota sin of same angle. Okay. And then there is some power which is integer. So what is the result? This power gets multiplied with the angle in both the terms. You can see now in place of cos theta we have cos n theta. In place of sin theta we have sin n theta. We can even verify this result. Verification is there. Okay. Suppose n equals 2. Okay. Suppose n is equal to 2. So if this property or theorem is true, okay, try to understand. Trigonometry will be used here. If this property is true, I'm going to actually verify it. Then if n is 2, which is an integer, then cos theta plus iota sin theta whole square should come out equal to cos 2 theta plus iota sin 2 theta. If the theorem is true, then this should be the result, right? Let us see if this is right or wrong. So what we are going to do? We are going to expand this square. How? A plus b whole square, which is a square plus b square plus 2ab. 2ab. Okay. Now we will use trigonometry and some concepts of complex number. Iota square is -1. If you remember, iota square is -1, and then you can write this as 2 cos sine and multiplied with iota. So if you remember, cos square minus sine square, this is nothing but cos 2 theta. Okay, cos 2a, formula of cos 2a, and this is your formula of sine 2a. So I hope we are at the same result. So this is cos 2 theta plus iota sine 2 theta, which is your RHS. Okay. So in the same way, you take any integer. You can take 3, 4, 5, 100, maybe a negative integer, say -2, -3, etc. Okay. What you can write? You can multiply that power with the angle and write it like this. This is called de Moivre's theorem. Now similarly, if there is a minus sign in between, okay, another result, similarly, you will use this also. Even if there is a minus sign in between, still the result is same. It will come out to be cos n theta minus iota sin n theta. This is also de Moivre's theorem. Okay. So if like plus is there in between, then plus will be coming. If minus is there, minus will be coming. Provided n is integer, I am repeating again and again. And integers can be positive as well as negative. Okay. Keep this in mind. So I hope this is clear to you. Let us solve some questions. Okay. Let us solve some questions on this. If z equals root 3 by 2 plus iota by 2 to the power 5, okay, plus root 3 by 2 minus iota by 2 to the power 5, then find this. Try related with de Moivre's theorem. Okay. Try to relate this question with de Moivre's theorem. You will be able to get the answer very easily. Yes, anyone? What you can write in place of root 3 by 2 plus iota by 2?
So cos pi by 6.
Yeah, that's correct. Good. So in place of root 3 by 2, you will write cos pi by 6, and in place of half, you will write sin pi by 6. Okay. What I said, cos of some angle plus iota of sine of same angle. So cos 30 is root 3 by 2 and sin 30 is half to the power 5. Because see, now you will be able to apply de Moivre's theorem to it. Similarly, it's minus here, so you will write minus. The problem is with this power 5, no, that will be no more. Why? Because this gets multiplied with the angle. Similarly, cos 5 pi by 6 minus iota sin 5 pi by 6. What happens? Question become very simple. Why? Because what will happen as a result of this, after using de Moivre's theorem, we see that this gets cancelled and ultimately we have a real number. What is z? Z is 2 cos 50 degree. Now cos 150 is some real value. If you want, you can write it. Okay. That value will come out to be minus root 3 by 2. Use trigonometry. Okay, minus root 3 is the answer, which is a purely real number. So what about imaginary part of z? 0, right? Because it can be written as minus root 3 plus iota 0. That is why. Okay. So one question based on de Moivre's theorem. Let me take the next example. You can try this first. Okay. The next question. Cos 4 theta plus iota sine 4 theta to the power minus 5. This is power minus 2. Okay. This is minus 2 power in the denominator. And cos 3 theta minus iota sine 3 theta to the power minus 9 equals cos k theta minus iota sine k theta, where k equals. So you have to find k, and I'm giving you the options. A 49, B 0, C 40, and D none of these. Okay. Try simplify this term on the LHS. All right. Compare it with the term on the RHS, and from there you will be able to get k. Just try this. Okay. Only de Moivre's theorem.
Sir, could you please scroll up?
Yeah. See, in some questions you may have to use de Moivre and Euler's formula simultaneously. Try to understand this thing. See, what is e to the power iota theta? E to the power iota theta is cos theta plus iota sine theta. Okay. What is e to the power minus iota theta? I gave you two results, remember? First we learned Euler's, then we learned de Moivre. So in some question I am saying that you may have to use Euler's as well. And then finally you can change the question using de Moivre's. And it is possible that you may not require de Moivre at all. Just try to understand. If we talk about the first term, okay, if we talk about the first term here, this is cos 2 theta minus iota sine 2 theta. Concentrate on this second formula, the one having minus. What is the meaning of this formula? See, whatever angle is here, the same angle appears in cos and sine, and minus is already there. Okay, so this minus is coming here. So now in the first term we have cos 2 theta minus iota sine 2 theta. That means It is e to the power minus iota 2 theta. Okay, using de Moivre's. Then sorry, Euler's formula. Then similarly, what about the next one? Now you can relate very easily. The in next one there is plus in between, so we'll be using this our formula. And since 4 theta is the angle, so I can write it as e to the power iota 4 theta to the whole power minus 5. Okay, now regarding denominator, I will solve this method by de Moivre as well. Here I am specifically using Euler's formula. Then in the denominator, cos 3 theta plus iota sine 3 theta is there. So I can write e to the power iota 3 theta and power is minus 2. Then finally, the last number, it is e to the power iota minus 3 theta because minus is there in between and power is minus 9. Let us simplify this. Okay. So e to the power minus this to the power 4. Okay. To the power 4. We will use this property of exponent that a to the power m to the power n is a to the power m into n. We multiply the powers, right? So the first term will be e to the power minus iota 8 theta because 2 will be multiplied with 4 using property of exponent here. Then similarly the next term will be e to the power iota minus 20 theta will be there. So I write minus here and 20 theta. Denominator, I am using same property every time. Okay, so minus 6 iota theta and minus is there, so 27 theta. Okay, now you can use property of exponent. What you get in the numerator, you get power minus 28 because powers will be added up, base is same, right? Basic concepts of exponent. And in the denominator here you get 21 theta. Now again property of exponent. Now you will use a to the power m by a to the power n, that is m minus n. So finally you will be getting e to the power minus iota 49 theta. Okay. You have reduced the given question to this form. Okay. And now once again I use second formula. Okay. This one. I have minus. Okay. And in place of theta I have 49 theta. So what I can write here, if I use Euler's formula once again, I'll be using cos 49 theta minus iota sine 49 theta. So can I compare it with this given form in the question? Yes, this is the question. So if you compare, what will be the answer? 49, that is A option will be the answer, because this is coming out to be cos 49 theta minus iota sine 49 theta, and in the question they have given that cos k theta minus iota sine k theta. Okay, so I have, this is clear. So I have solved the whole question with the help of Euler's form. Now if I want to solve this same question using de Moivre's theorem, right? So what are the options I have? Let us see. See in method 2. Okay. Now I'm not going to use Euler's, I'm going to use de Moivre's. So powers will be multiplied with the angles, right? So what will be the first term? 2 theta minus iota sine 2 theta to the power 4. So it will become 8 theta. This is the first term. Okay. Then similarly next you multiply minus 5 theta with 4 theta. Okay, or you can compare it with that second property, that if minus is there in the power, see this cos theta minus iota sine theta to the power n, this can be written as cos n theta minus iota sine theta. Either you can use this property or you can use the first one only, and you multiply minus 5 angles, so it will be cos of minus 20 theta. Okay, plus iota sine. I hope you are getting it what I told you. I told you that whenever power will be an integer, okay, it will be multiplied with the angles. Just remember this. Then similarly in the denominator, minus 2 will be multiplied with 3 theta. So minus 6 theta plus iota sine minus 6 theta. Then finally in the last one, power is minus 9. So cos of minus 27 theta minus iota sine minus 27 theta. Okay. Now Let us simplify further. So this is cos 8 theta minus iota sine 8 theta. Now use some trigonometry. Okay, in trigonometry, cos of minus x is cos x, so it will remain 20 theta, while sine of minus x is minus sine x, so minus will come outside and it will become this. Okay, use this same property again and again. It will be cos 6 theta minus iota sine 6 theta, and next one is cos 27 theta plus iota sine 27 theta. What are the concepts used in this step? That cos of minus x is cos x and sine of minus x is formula of trigonometry. Okay, minus sine x. After you have written all this, now comes the important part. Okay, now comes an important part. If you have to solve it by De Moivre, comes an important step. Listen carefully. I can write this as this is important. Okay, like this. Why? You can do it in the opposite way. If like minus 8 power is here and you use De Moivre's theorem, what it will become? Okay, what you can write in place of cos plus iota sine to the power minus 8, what you can write? You will write it as cos of minus 8 theta plus iota sine of minus 8 theta, right? Now cos of minus x is cos x and sine of minus x is minus sine, isn't it? So that means this can be written like this. Keep this in mind. Okay, so similarly, what about the next term? We can use the similar process. It will be cos plus iota sine to the power minus 20. I am going to change everything in terms of cos plus iota sine. This will be power minus 6. Okay, this will be power minus 6. And what about the last one? This can be written as cos theta plus iota sine theta to the power 27. What do you observe? You have same kind of terms. You have cos plus iota sine as the base in every term. So now you know that in the numerator powers will be added up. So it will become cos plus iota sine to the power minus 28. Okay. Denominator it becomes cos plus iota sine to the power 21. Okay. Then again use property of exponent. So 21 will be subtracted from 28 minus 28. So this can be written as minus 49. Okay. Use De Moivre's theorem one more time and you have the answer. Cos where angle gets multiplied with power, right? So what you can write here? You can write cos of minus x is cos x, so cos 49 theta minus iota sine 49 theta. So what is k? K is 49. Okay. So in the first method I have solved the question. Okay. In the first method I have solved the question using De Moivre's, sorry, using Euler's. And the second question I have changed the question specifically using De Moivre theorem. Okay. So they go together either by Eilers or by De Moivre. Okay. So I hope this is clear to you. Okay, then solve this question. Okay. You're free to select any of the options. Either you can go with De Moivre or Eilers. Okay. Just tell me what you are getting after simplifying this expression. Try this question. Tell me what you are getting.
Sir,
Yes.
can you please scroll up a bit? Thank you, sir.
All right. Now everybody try this question.
So one.
Yeah, one is correct. Just wait a minute. Yeah, can you explain the answer, because I'm just a little bit concerned the way you have got it. What exactly you are doing here in this question?
The Maeva thing, the formula, and then I just uh, rationalized at the end.
I just want to know, have you multiplied this power 8 with both the terms? Are you multiplying 8 with pi by 8 in both the terms, in numerator and denominator? Are you doing it?
So yes.
No. See, there is a mistake. Try to understand, but it is okay. It is okay. At least now you will not repeat it. See, the formula is cos theta plus iota sin theta is cos n theta plus iota sin theta, right? This is the formula. Agree? But if you look at this form, the question is like sine plus iota cos, right? I want to tell you something important. Sine plus iota cos to the power n, this is not at all equal to sine n theta plus iota cos n theta. I never said anything like this. That sine plus iota cos to the power n will be this. Only this form. Okay. So this is an important question in that term. That means what else you need to understand? Term of iota should be with sine. Okay. Or iota should be with sine and cos should be without sine. But see, it's just the opposite is happening here. So De Moivre's theorem is not applicable. It has no formula as such. Okay. So now this is the task. Now you may get the same answer. But technically, since the concept is wrong, so I won't say that this is the right way. Okay. Now, can anyone tell me how to change this into cos and this into sine? Do you have any method to do it? How to change sine pi by 8 into cos and cos pi by 8 into into sine of the same angle? Do you have any method or any technique to do it? Yes, anyone? So I'm writing one thing so that you do not repeat this mistake. Okay, this is not equal to sine n theta plus iota cos n theta. Okay, see, for this you need to use trigonometry. What is the problem? Sine pi by 8, sine theta is cos 90 minus theta. Remember, reduction formula. This is theta, this is theta. What is the formula? Sine theta is cos 90 minus theta. Solve this. So this will be 3 pi by 8 after taking the LCM. Similarly, so first you use trigonometry. Cos pi by 8. Cos pi by 8 is cos theta is sin 90 minus theta. This is sin 3 pi by 8. Okay. Write like this first. So sin pi by 8 is cos 3 pi by 8. Cos pi by 8 is sin 3 pi by 8 to the power 8 divided by, repeat same thing in the denominator, cos 3 pi by 8 in place of sin pi by 8 and sin 3 pi by 8 in place of cos pi by 8. So just a simple application of trigonometry can now change this question in terms of de Moivre's theorem, right? Now you can do this thing, multiply by 8, right? So this will be cos 3 pi plus iota sin 3 pi, because when 8 gets multiplied with the angle, so it gets cancelled. Here it is cos 3 pi minus iota sin 3 pi. Now again some basic trigonometry will be used because 3 pi is the standard angle. Okay. Cos 3 pi means cos 540 degree and the value will be -1. Why? Because 6 rounds of 90, that means no change in cos, angle will be 0. But after 6 rounds of 90 it will come in third quadrant because plus something is there. Okay. So value will be -1. I have taught you everything. Okay. And sin 3 pi, this will be 0 because sin n pi is 0 if you remember. So from there also, from the graph also you can tell that sin 3 pi will be 0. So what will be the result? This is -1 upon -1. This comes out to be 1. Okay. So 1 is the answer. But see the approach. Okay. And take care of this thing, that this is not equal to sin n theta plus cos n theta. Okay. Important question. See, sometimes now this is a kind of, we can say, a concept. Okay. Questions based on logarithm of a complex number. That means sometimes you have to take log of complex number. Okay. Just listen carefully. Whatever we do, that is a kind of theory. Again, questions based on logarithms of complex number. And then there is one more article called nth root of unity. Okay. With this we will end this chapter. And there is some part in complex number which is related to the geometry. Okay. And that will be covered along with coordinate geometry. So first you understand what are straight lines, circle, parabola, ellipse, hyperbola. You complete conic section and circle. And then when you understand the geometry part there, okay, you will be able to use, or I mean able to understand the Geometry part of complex number. Okay. So because see, whatever we study in coordinate geometry, there is a Cartesian plane, x, y axis. Now similarly, there is Argand plane, imaginary real axis. So it is somewhat related. So first we are discussing about the logarithm of a complex number. See what type of question they ask. What type of question they ask? Like for example, the question is find the value of. This is a very important question. Okay. Find the value of z equals iota to the power iota. Okay. Z equals iota to the power iota. Now you know what happens. It looks like that it will be a non-real number, right? Because iota is root of -1. Okay. So root of -1 to the root of -1. So it looks like it will be a non-real number. Now I'm going to show you something very important. Just concentrate and listen very properly and observe each and every step, because though it may be a question, but it will be acting as a standard solution or the working rule to solve such type of questions. Since there is power of iota and it itself is a complex number, so in such type of questions, okay, in such type of questions where non-real number is there in the power, we will proceed by taking log both sides. Okay, we will proceed by taking log both sides. Remember, whenever complex number is in the power, okay, we will take the log. So and log will be taken on the base e. This is another important thing. Okay, take log on base of e. So I will solve one more question. Okay, so that will make it even more clear. Take log on base of e. Now nothing much can be done on the left hand side, but on the right hand side you can get iota here. Why? Because log m to the power n is n log m. Okay, there is some base n log m. Okay, now the next important thing is how to write iota. Okay, now you will say how to write iota means what? This is important here. Iota is 0 plus 1 iota. Okay, and now you have learned Euler's form and this de Moivre's theorem. Okay, so in place of 0 you can write cos pi by 2. These are the important steps. And in iota you have to write sine of the same angle, so you will have to think that what are those angles whose cos is 0 and sine is 1. So not that difficult. Cos pi by 2 is 0 and sine pi by 2 is 1. Okay, and then you will think about Euler's notation. So cos theta plus iota sine theta is e to the power iota pi by 2. Now try understand this. You can write iota like this also. So I am going to write iota as e to the power iota pi by 2. Okay, this is your general form, this is polar form, this is Euler's form. Okay, you need to write this complex number, okay, in Euler's form. Now what's the next step? Again this power will come in multiplication, so this iota pi by 2 will come here, and what will be left? Log e base e. How? This same step. Now log z base e iota square is -1 minus pi by 2, and what is log e base e? That will be 1, since log of number to the same base is always 1, that is why. Okay, so log of z base e comes out to be minus pi by 2, and with this we come to the end of the question, because if I want to remove log from here, I will take e to the right hand side and minus pi by 2 goes in the power. This we have already discussed. This was the first topic that I taught you. Okay, so this is z equals e to the power minus pi by 2. What do you observe? Have a look at the question. What is z? Z is I to the power I, or iota to the power iota. And what you are getting here? You are getting same z as e to the power minus pi by 2. And you know what is this? This is purely real number. Purely real number. You can, this is not Euler's form. Okay, now some of you will be confused. Euler's form or Euler's form, whatever you say, this is different. Okay, e to the power iota theta. It is not this. Where is iota? Not present here. Okay. So what kind of number is this? What is e? E is 2.73, 2.71. What is the power? Minus pi by 2. Is there any non-real number involved? No. So what kind of value is this? This is purely real number. Okay. You cannot change it further. It is already in the simplest form. Okay. So what was the question? Find the value of iota to the power iota. What do you observe? This is a real number and it seemed like a complex number, iota to the power iota. But when we simplified this, we got this as a real number. Now try understand this thing. Whenever there will be complex number in power and you have to find the value, you will assume it some complex number z. Okay, you will assume it some complex number z and start by solving log both sides on the base of e and then use properties of log. Let us solve one more question on this. Find the real part of, find the real part of 1 minus iota to the power minus iota. Okay, this is the question. You can just try it. Okay, see, this is the solution of the previous question. Okay, and the question is written just below it. You can see these steps and you can try to get the answer of this part. 1 minus iota to the power minus iota. So if you observe the steps, okay, first of all I take is as Z, okay, take it as Z. Then what is the next step? We take log on the base E, right? So log of this number, then minus iota will come here using property of log. Now the part is this one. This is important. We have to write 1 minus iota first in polar form, then in Euler's form. Okay. So if you remember, only then you will be able to change it. Okay. So it may not be possible that you directly assume this as cos of something and whatever coefficient of iota is there with sine of the same angle. So what you can do, just go back to that question where you used to change this question in polar form. Okay. So if this is your 1 minus iota, then what is the modulus here? Modulus is root 2. Okay, root 2. Now we have to find that argument thing. So tan alpha is mod y by x. Mod y by x. So this is 1. Alpha is pi by 4. Where the point is situated 1 comma minus 1. X positive, y negative. Fourth quadrant. So argument of z will be minus pi by 4. Now how to write the same thing? r into cos of theta plus iota sine theta. Okay, and now you can change this. This is the polar form. Now you want to change it in the ILS notation. So what you will write, e to the power iota theta. So now this minus can be written like this. Okay, this is the way to change this standard form into ILS notation. I told you that you will have to change it in that form only. So now you can write it as root 2 e to the power minus iota pi by 4. Okay. Now you cannot write this power directly here because root 2 is also present. So first of all, you will have to use property of log, that is log m into n is log m plus log n. Okay. Like this you will have to write. Then what is the next thing? Again you can use property of log, and this thing root 2 can be written as half log 2 base e. Why? Because if anything is in the power of the number, it comes in multiplication. So root 2 means 2 to the power half, like that. And here you can write minus iota pi by 4. Power will come in front once again. Simplified once more and you will get the answer. This is half log 2 base 2. Log 2 base e, log e base e is 1. This is iota pi by 4. Okay. You multiply this term. What you will get? Minus iota into half log 2 base e plus iota square pi by 4. So this is like simplification part going on. Okay. So this is how much? This is minus iota by 2 log 2 base e. Iota square is minus 1. So minus pi by 4. Okay. Finally, you have to find z, no? So you will take e on the other side and this thing will come in the power. Now use property of exponent, that a to the power m plus n can be written as a to the power m into a to the power m. So you can write it as e to the power minus iota log 2 base e by 2 into e to the power minus pi by 4. Okay, e to the power minus e to the power minus pi by 4. Now see, first one is of Euler's form or Euler's form, but the second one is a real number. So you write e to the power minus pi by 4 and the next number, okay, the next number is in this form and you will write it as cos theta minus iota sine theta. Okay, and what is theta? Whatever is written after iota, that is theta. So how to change this thing? Cos of the angle minus iota sine of the angle. Okay, this formula, minus iota sine of this angle. Let's see what is the question. What is the real part? So now you can easily write the real part. Real part of z, which is the question actually. See this thing. This is your real part. Because when you will multiply e to the power minus iota pi by 4 with the second term, no, it will come with iota. But what was the question? Find the real part of the given complex number. So the answer is going to be e to the power minus pi by 4 cos of this angle. See, there is no iota anywhere or no real non-real value. So this will be your real part of this complex number. Okay. So mainly you have to take log. Okay. Mainly you have to take log and then use the properties of log, and some place you have to use Euler's notation. Okay. If anyone wants to note it, you can note it down. Okay. Yeah. Now, what about your homework? That PNC question bank. Ask your doubts from there. Yes, students, your doubts from level 1 PNC. Hurry up. Anyone having any doubts? No doubts at all. You can solve all the question, man. Very good. Who will tell me how to solve question number 22 from PNC question bank level 1? How to solve question number 22? This is the question. N square minus n c2 equals n square minus n c10. What is the value of n? Options are given, but that is not important. How you will solve this question? Come on, Arya, let me know. No? I think Nikhil, you have written some questions 24, 27 and 31. Okay, I will see here. Let me. "24, 27 and 31. These are the three doubts that you are asking. See in question number 24. Question number 24. What is given? In an election, 3 persons are to be elected from 6 candidates. There are 6 persons. Okay. P1, P2. Wait a minute. P1, P2, P3, P4, P5 and P6. Suppose 6 persons are there. Okay. They are fighting an election. Okay. And a person is there. He can cast any number of votes, but not more than the candidates to be elected. And how many of them are to be elected? 3 are to be elected out of 6. So number of ways in which person can vote. Number of ways. See, generally we give only one vote, right? But here it is given that a person can vote any number of votes, but not more than the number of candidates. So either he can select one out of these 6. That means he can give vote to any one person, or he can give vote to 2 persons, or he can give vote to 3 persons. But not more than this, not more than the number of persons to be elected. Now use formula of NCR and the values will come out to be these. Okay, and this will be equal to 41, which is a option. So either he can select one. Select means either he can give vote to one person or 2 or 3. So this is like selection NCR. And let me solve question number 31 first. Okay, it is numerical based question, but it is a very good one. Alpha is MC2 and you have to find alpha C2 in terms of M. That also in terms of combination. Okay, just wait. So first of all we will solve this. No, this alpha equals MC2. So this will be alpha equals M factorial upon M minus 2 factorial 2 factorial. Simplify this further. This will be m into m minus 1 into m minus 2 factorial. You know how to change this, right? And in the denominator you have 2 factorial, which is 2 only, right? 2. Cancel this. So alpha comes out to be m minus 1 by 2. Now you put this value here. Okay. First you simplify this as well. So alpha C2 will be how much? Alpha factorial, alpha minus 2 factorial, 2 factorial. In the same way, just like this MC2, you will simplify this and you will get alpha minus 1 by 2. But this is not the answer. If you look at the options, you have to change it in terms of m. So you put this here. So this is m minus 1 by 2. Then m minus 1 by 2 minus 1 upon 2. Okay. Take the LCM and simplify it. M minus 1. This will be m square minus m minus 2, and in the denominator you will get 8. This changes to m minus 1. Make the factors m minus 2 m plus 1 upon 8. Okay. Write it in the descending order. You write m plus 1 first, then m minus 1, then m minus 2 upon 8. Okay. Now you have to change this thing. This is the final answer, but you have to change this in the way the options are given. And options are given in terms of like NCR. So what I am going to do, the last step, I am going to multiply the missing terms. Okay. So after m minus 2, what will be coming? M minus 3, m minus 4, and this goes on up to 1. So whatever is remaining, you multiply, and if you multiply, you will have to divide it also. Okay. You will have to divide it also like this. So what will happen? What you observe in the numerator? In the numerator you have observed m plus 1 factorial now. What is there in the denominator? Leave apart 8. This is m minus 2 factorial. Okay. Try to change it in formula of NCR. Try to change it in formula of NCR and listen. This m plus 1 and m minus 2. If you take the difference, this will come out to be 3. This will come out to be 3. So if I write, try to understand this. And what is factorial of 3? Factorial of 3 is 6. Okay. So what I am doing, one more step. Okay. I am multiplying and dividing by. So this is a good question, I told you. Okay. You have to just do some manipulations also. After you multiply and divide by 6. Okay. Multiply and divide by 6. Then what is there now? What is remaining? This part can be written as, wait a minute, m plus 2, 3 factorial will be there. Okay, sorry, wait a minute. Actually, I have written this wrong. This is not m minus 2. The missing term was starting from m minus 3. So if in the numerator I am multiplying by m minus 3 in the denominator also. So it will be m minus 3 factorial. Okay. And then the difference will be 4. Okay. So 4 factorial. 4 factorial. Wait a minute. You multiply this by 4 factorial and you divide it by 4 factorial. Now 4 factorial is 24, 24 upon 8, and you write this remaining term like this. I am trying to change it in formula. Okay. Now what is 24 by 8? 24 by 8 is 3. And what about this? What is this written? Change it in terms of NCR. So it will be m plus 1. This is sorry, m minus 3. No, it is m minus 3. I change it to m minus 3. So this is m plus 1 C4, because if you use the formula of NCR, it will be m plus 1 factorial, lower number factorial, difference factorial. Okay. So after we get this number, see, this is the final answer. Okay. What we are doing, we are trying to change it in the formula of NCR. So for that, I multiplied with this term, see. And if I have to multiply, I will have to divide it also. So first it changed to m plus 1 factorial. Denominator, this is m minus 3 factorial, and 8 is there. Then what else I did? I observed their difference. Difference of m plus 1 and m minus 3. It came out to be 4. So this is 4. I multiplied and divided by 4 factorial. Then this 4 factorial upon 8, this comes out to be 3. And the remaining part, this part, I changed it in terms of NCR, and it came out to be m plus 1 C4. Okay, that is why you may be thinking that the difference is 4, so you should have multiplied and divided by 4. Why by 4 factorial? Because in formula of NCR, no, r factorial comes, not r, right? So difference is r, or the difference is n minus r. Okay, but we do not multiply and divide by n minus r, we multiply and divide by n minus r factorial. So that is why 4 factorial is the term by which I am multiplying and dividing this thing. Okay, so question is a little bit lengthy, but you know the calculation part, this will be done like this only. Now finally I'm taking question number 31. Oh sorry, this 27th. And that also we have the second part. So father with 7 children takes 4 of them at a time to the zoo as often as he can without taking the same 4 children. Okay. So how many will he go? Actually, he'll be going in 7C4 ways, right? See, father will be going every time. So father, you have to select 1C1. And out of the remaining, out of the 7 children, he takes 4 of them at a time. So number of ways in which he is going to the zoo is 1C1 into 7C4. 7C4 will be, I think, 35. Okay, this value. So father will be going to the zoo 35 times. And regarding this, the second question, how many times each child goes? Okay, suppose these are the children C1, C2, C3, C4, C5, C6, C7. Now the father is taking 4 children along with him. So obviously there will be a situation when a particular person will be going again and again. Like for example, these 4 are going C1, C2, C3, C4, or like these 4 are going. So like C1 is going once again. This will be happening. So this is the question. How many times each child will go? So first of all, each child, that means we have to arrange, we have to take this, confirm, we have to select him. Now how many kids are there? 6. And out of these 6, we have to select only 3. Because in all 4 children are going to the zoo every time. So this comes out to be 20. So 20 are the number of ways in which C1 will be going. How many times father is going? 35 times. Okay, how many times each kid is going? 20. I have just taken the example of C1. Each kid can be any of these 7. Like for example, you want that C2 must be going. So we have to select him. Now the remaining 6, in from among them I have to select 3. So 1 C1 into 6 C3. So again it will be 20. Okay. So each child will be going 20 times. So I hope this second part is clear to you. Now if anyone is having any doubt, please speak up rather than typing there. Anyone having any doubt in these questions? PNC. Till question number 60. Till question number 60, any doubt? See, I am giving 2-3 days more. Like this is Monday. So till Thursday, complete this exercise. Okay. Till Thursday. After Thursday, I'm not going to discuss this question bank. So you have 3 days more. And if we have done 60, 144 questions are there. Okay. So remaining 80 questions, divide 25 each on every turn and ask the doubts. Okay. Till tomorrow, ask till question 85. After that, they will not be discussed in the class because you are not doing it. So I can't help it. Anyone having any other doubt till question number 60 can ask. Because see, yesterday, tomorrow's class, we will complete a complex number also. So then its question bank will be there. How much time you need? Any other doubt till question number 60? No doubts then. That's it for today. I will continue in the next class. Okay, only one topic is remaining, that is nth root of unity. Okay, cube root of unity we have already completed and this chapter will be complete as well. Geometry part, I'm telling you, no need to solve any question from geometry part of complex number. That will be completed along with conic section. That will be the end of the 11th syllabus. Okay, not right now. That's it for today. Thank you.